graphing 2D kinematics. In order to graph 2D kinematics, it's the same basic principles that you use for graphing 1D kinematics. However, the only difference is that now you need to break it up into X and Y components. This same principle was taught to you when you were given a general velocity and you had to again break it up into X and Y components by using trigonometry. You're always going to be graphing a projectile and it's always going to be in a position versus time graph. So, for example, if a purple zebra was to jump off a 105 metre high cliff, as represented on the y-axis, and it was to jump 238 metres off of that cliff, and then was to fall 543 metres, then this is clearly shown from the positioning, and then it would take 15.6 seconds in order to reach the floor. The way that you calculate these numbers is by using the 2D kinematic formulas which you've previously learned.
Another thing you can do with graphing 2D kinematics is by breaking it up into smaller graphs by doing acceleration versus time, velocity versus time, and position versus time, which you again need to break up into X and Y components.
Alright, so let's start by graphing things in the vertical direction. This is always going to be a bit trickier because the velocity is going to be constantly changing in graphing 2D kinematics. So if we start with a position versus time graph, the slope is always going to be what the speed, the velocity is. So if it's a negative slope, then the velocity is negative. If it's a straight across, then it's going to be stopped. And again, this is going to be negative. If it was to go up like this, then the velocity would be positive and the velocity, it would be speeding up. So if we then look at a speed versus time graph, then we can see that the slope is going to be what acceleration is. So again, if it's a negative slope, then negative acceleration. Here, if it crosses the x-axis, this means that it has a velocity of 0. This is going to be when like an object has reached its peak height, because then it's going to pause and have no velocity, which means it's going to then change direction. So every time it crosses this point, it means that it's changing a direction. And then again, here you can see the acceleration is negative, then constant velocity, and then increasing acceleration. However, don't be tricked, because just because it has a negative and positive acceleration, it does not necessarily mean that it is decreasing speed and increasing speed. Now, if we look over at an acceleration versus time graph in the y direction, it is always just going to be negative 9.8 for the acceleration, because it's always just going to be functioning under gravity the entire duration of the projectile motion. In order to find the variables to plug in for these graphs, you're going to have to use the kinematic formulas, which you are allowed to use because the acceleration is going to be changing. If we switch to the horizontal direction, things get much easier because, as I've said previously, if we are graphing the projectile, then x is always going to remain a constant speed. So this means that on a position versus time graph, the slope again is going to be velocity, however you're just going to maintain a solid straight line because the velocity is not going to be changing. And then here, when you're doing a velocity versus time graph, you can just draw a straight horizontal line because you don't need to draw any sort of slope, because that would imply a fluctuation which isn't going to be present because it remains constant. And since it remains constant, your acceleration in the x direction is always going to equal 0. So this is very simple to draw because you just draw a straighter horizontal line on the x-axis.